Live at the command center of the JW Solar USA in Minnesota. Guys, finally, I was able to charge these 18650 Panasonic batteries fully charged, because the inverter, which is the MMS 1210 inverter, you guys have seen this guy here. If you haven't seen it, go back to my videos. You see Magnum MMS 1012 cannot charge these batteries all the way full because of this specification. It sits at a certain voltage that 15 to 16, 15.9, so it can't go further. So finally, the batteries are charged, and I shut the system in a way that it can continue with the solar. The solar is programmed to go all the way to it's supposed to be 16.8. Then I went according to the battery specifications, it's a 4.2 volt. So I decided to tweak it to go higher than what the inverter charger can do. If you look at here, you can see it's 16.5. So it's a fully charged. So 16.4 is saying float, bouncing back and forth. And what I did, I forgot to make the video. I incorporated a smart shunt made by Victron Energy. So I just put it here so that I can able to monitor it through my tablet or iPhone or whatever you want to call it, smartphone. So I incorporated this one, and it's doing a pretty good job. So I program everything, and I already have this for quite a while, but I never just discuss about it. And I was thinking, I was waiting for time, then I'm gonna do this. And it has a Bluetooth capability. So from the lithium batteries underneath, this is the in. You can see this one to the battery minus, and this one goes right here to the bus, so that I can monitor the loads that we're taking off. So now we can able to do a full capacity. I was always gonna do that, but this thing cannot let me if I charge it through the system. And the panel, I just laid it. It doesn't mean it's really angled to anything. I just drop it on my deck, so it collects every sun that he wants to, and the system was just running perfectly, running the fridge and the refrigerator simultaneously. And okay, upright refrigerator, freezer, plus a regular refrigerator that has a freezer on top of it, which is not upright. So this system has been running the house closely a month now, just on this guy. Now we already went to a almost full capacity, which is 16.5. Then we're gonna do a full capacity test on these batteries here. The shunt incorporated here last week, which I didn't discuss about, and I'm sorry if you guys are really interested into this. If you're interested how this thing is installed or programmed, let me know on the description below, then I can make a video and show you how to go about it if you've never done it before. Okay, so I'll do that because there are a lot of videos out there, but everybody's video is different. So this is what it is, and we can go capacity test on this. And the batteries are 95.04 watt hours. So calculate that by 34 modules here. It's a 6.6 amp hours. 6.6 amp hours on each module. Okay. So it's rated at 14.4 nominal, but you can charge them with 16.8. So we are close on the 16.5. Then we're gonna test it, and we're gonna turn the tablet on and see what it is, how we're gonna run the system. like and subscribe. Here goes our tablet right here. We're gonna have it on. I don't know if it's already on now. You have to turn it on. This is an Asus. It's about 10 inches. So we're gonna light up this thing and set up the app. The app is already set up, so it's just a matter of connecting. I'll show you some of the sequence we have to go through. It's powering up. Here goes the app. So what we're gonna do, we're gonna go here and turn the Bluetooth right there. I think it's already on. There you go. So Bluetooth is gonna find that. We have to make sure we have our location on, okay, which is already indicated before it's gonna work. Now we're gonna click onto the Victron, and it's gonna show us the device connected. There you go. That's the Victron, and click on this. It's gonna try and connect. There we go. It says there's a 99% state of charge, and you will see all the stuff that was already. It says 10 days. So let's see, it's gonna cut up, and it says on the the Magnum is 16.5. It says 16.4 here, and 16.4 on the Midnight. So I don't know which one is right. And this meter is in 16.5. I set up the batteries already, and it has a lot of cool features here. You can able to say monitor just the voltage, and which is already indicated right there. And we monitor the power, which is the watt. So it's gonna show us right there, and we can go here. It's gonna give you a whole bunch of stuff. Okay, so the max charge today is 16.5, which was the minimum was 15.8, so we brought it up to 16.5. And we can go up here and program the battery, which we already did. The capacity of the battery, so it's 24 amp hours. See, 16.8. I try to do it a full charge. That was due to a specification on the thing. So if you're curious, those are my settings for the batteries. If you have a better settings, you think this is how the Victron works, let me know on the description below. So these are my settings I'm sharing here with you guys. Let me know what your settings are. If you're running the 18650 Panasonic batteries, I will put that on the end screen. There you will know exactly what batteries I'm talking about from battery hookup. And this is what I set up. So we go back here, and I set up the alarms. The alarms are there, 30%. And I'm gonna go back here, miscellaneous. I just use turn the auxiliary off, and so just to monitor the battery. That's what I wanted. But when you flip the screen, this is if you're gonna use the VE Smart Network, and I don't have that because you have like a inverter. You have a lot of the Victron equipment. Then you can able to route all these things. Everything's gonna able to talk to each other. Okay, so as long as you're dealing with the same company, the same equipment, you can able to do anything you want to do. So what we're gonna do, we're gonna reset the meters here until we'll run these batteries till they die. All right, so now we already reset the meters, how much power. You can see the charge and the discharge. This is what we want to know. How many kilowatt hours we're going to be pulling from this battery. So if you calculate 95.04 watt hours to 34 modules, you will know exactly how many kilowatt hours. Like about 3 point something kilowatt, 3,500 watt hours. So that's the deal. So let's check it out and see how everything works. Like and subscribe. jwsolarusa. Okay, this is what is happening right here. Let's try it and see how many watt hours. Like and subscribe. Let me interrupt the system and see how many watt is coming out. Look from here. I'm gonna search the two refrigerators at the same time, and you're gonna see they don't like that because of the spike, the surge. See how much power is kicking right now. 718 because I searched the inverter, the load. So the inverter is running crazy now. So now we're gonna start the counts. So it says about 16 hours something instead of 10 days we were talking about. The compressor just shut off. So they're gonna be starting very soon. Now it's just taking about minus 17 watts, 1.07 amp at 16.3. So this is how we're gonna start the system. Okay, like and subscribe. I'll show you when the compressor is kicked in again, and you will see how things go. Now you can hear the inverter making noise. The fan is running because of I interrupted the system, just like I interrupted by surging the system, and everything just spiked. You can see I forgot to even see how many amps were coming out, but that was 700 something. And the freezer and the refrigerator freezer and the upright refrigerator freezer doesn't take any power at all. Okay, so let's wait and see. While the system still showing here, the two lights are on, like the float, and everything is full. Okay, all right. Trying to disconnect the solar and see it's gonna do anything. There is no sun anymore. It's evening now here. Sorry, this video is gonna be a little bit longer, but anyway, guys, this is what it is, and we just have to. Yeah, just have to bear with me and we can go through all the process here. Alright, bye for now. Now it says searching because they don't like when you interrupt it, like they feel like a power failure or something. So I just tricked it, and you can see just like raving, like RPMs, it goes all the way. There you go. You see the surge? One of the freezers just kicked in. You see a fault light came on right away here because this inverter is a little, but it surged 2 times the capacity. Something just happened. Okay, it's trying to start. Something just happened there. It's gonna come back for the second time. Already put in here, but you will see. Like and subscribe. Stay tuned. We just missed that. It surges and it just started up again, the compressor, after being interrupted, and we pull in some power, and can't even show anything on this meter because it's lesser than the threshold. So here it's pulling about 8 amps, as you can see. And let's go into the history. You'll see a lot of good stuff. Look at that. This is the last time it was charged at the minimum voltage, and now this is the max. So we're going to be looking the discharge energy. That's what we're going to be working on now for so long. But I got to plug this guy before it dies because it's 40% still a charge. And this, look at all this graph. That spike that just happened. And I can interchange this. I can go here and use the voltage on this side and use the power, which is the wattage, on this other side. So right now, if you're looking at it, we're running at 1. It surges first at 102. So look what is happening here. This is the graph right now that is going through. So it's below 100. Yep, 100 and something here. So this is what is doing. So I hope you like the video. Like and subscribe. From the command center of the JW Solar USA in Minnesota, thanks for watching. Bye for now. No more solar coming in. It's not enough to pull any of this to show because this one doesn't have the BMK. So we using the Victron Smart Shunt, 500, 50 milliamp to 500. So I was thinking about getting the 1000 or 2000 amp hours, but that's going to be on the next video. See, I have another meter coming up soon, and we'll go from there. Okay, thanks for watching. Love you guys all. Bye for now. Alright guys, before I let you go, this is what I want to show you. To the refrigerator, freezer, or upright, and the upright refrigerator, freezer, both of them are running. They only pull about 120, 121 and flickering, and it pulls only about 7.29 amps. That's all. This is the power I'm consuming in my house when it comes to freezer or fridge. They don't take power at all because all of them are Energy Star. So both refrigerator and freezer, they're all running at 120 watt, 7.25 amps. I just want to show you guys. All right, thank you. Bye bye.